Okay, we have a situation where fencing costs $18 per meter, and we have a budget of $8,000. We want to make an enclosure like this with 4 sides of length W meters and 2 sides of length L meters. And this fencing all costs $18 per meter, so the total cost is going to be $8,000, and that's equal to the cost is $18 per meter, and the number of meters is 4 W's plus 2 L's. And so, let's see, we can factor a 2 out of the parentheses, so this is 8,000 is equal to 18 and 18 is 36 times 2W plus L. I factored a 2 out, which doubled the 18 on the outside. Now I can divide both sides by 4. And this gives us 2,000. 4 goes in 36 9 times 2W plus L. Or 2,000 is equal to 18W plus 9L. At this point, we want to look at the area equation. That's what we're trying to maximize here, is the area. So the area is the length times the width, simply. So we want to substitute one of these variables in terms of the other one here. Let's solve for L. If we solve for L, we have to take away 18 W's from both sides. And so we get that 2,000 minus 18 W's is equal to 9L. Dividing both sides by 9, or multiplying both sides times the 9th and distributing it, we get that L is equal to 2,000 divided by 9 minus 2W, because 9 goes into 18 twice. And that's L, this is all L, times W. So once again we found we have a parabola here. The area as a function of W is a parabola. It looks, here's the area, and here's W. And it's a parabola that looks something like this. And its maximum, well, at its vertex, you'll find the maximum area. So let's find the vertex of this parabola. Let's write it in a more standard form first. So we write this as negative 2W squared plus 2,000 divided by 9 times W. So the W coordinate of the vertex, that's negative b over 2a, is negative 2,000 divided by 9, all divided by 2 times a, which is negative 2. So what we end up getting here, the W, the measurement W in meters that will give you a maximum area is this, and the negatives cancel out, and this is like 2,000 over 9 times 1 over 4. 4 goes into 2,500 times. So we end up with 500 divided by 9, and that's in meters. That's the dimension that will maximize the area, and now we have to substitute that value into our equation up here for the area to find the maximum area. So that's what we have to do last here. Substituting this value of W into the equation up here, we get the maximum area. So it's 2,000 divided by 9 minus 2W, but W is 500 divided by 9, and that's times W, which is again 500 divided by 9. So if we evaluate this, we've got it. Now this is 2,000 divided by 9 minus 1,000 divided by 9, times 500 divided by 9. So that's 1,000 divided by 9 times 500 divided by 9. So the maximum area, consulting the calculator here, we have 1,000 times 500, which is 500,000, divided by 9 times 9, which is 81. And so I get a maximum area of 6,172.8395 square meters. We're supposed to round this off to the nearest square meter, so the 8 will cause that to round up to a 3. So our maximum area for a budget of $8,000 is going to be 6,173. Whoops. 6,173 square meters. That's the maximum possible area.